Okay, guys, just like our normal equations, we also have equations that are under the surds, focusing on the surds. Remember, we talked about the introduction of these surds. How do we apply these surds and some of the rules and laws? We also have the part of solving of equations, all right, where we are asked to solve for x given particular questions. We're just going to explain what are the stages that you're supposed to make in solving of these typical equations. We're given the square root of x plus 2, which is equal to 4. So when you are to solve equations like this, all right, already this is in the right format that we are supposed to have. What is the right format? The right format is that you're supposed to isolate this, the surd that you're given. We are supposed to isolate that, to isolate the surd, the part that is under the square root, to be on its own, that is to isolate it, to make it the subject of the formula, that is to make the subject, make make the surd, all right, the subject, all right, the subject. So you're gonna make this the subject of the formula, all right. You are simply making this the subject, all right. So in this case, it's rightly exactly what you're supposed to have it. When you have this, what are you going to do? You are going to square both sides. After you've isolated this, make sure that you square both sides of the equation. Why are we squaring both sides? We know that by squaring both sides, we are automatically removing this square root. To square, remember the square root, when raised to the exponent of 2, we are simply removing that square root, all right? Because the square root means to the exponent of what? Of a half. So we are simply squaring both sides. So meaning to say also this must be squared. All right, so like I said, to square means we are simply removing what? The square root. So we'll be left with what is under the square root, which is x plus what? X plus 2. And this is equal to this one. You can simplify 4 squared. That is 4 times 4, which is 16. So to find x, guys, this is now a normal equation. You can now solve. After this, you can now solve. All right. So transpose 2 to the other side of the equation. It becomes what? A negative. That's 16 minus 2 in this case, which is going to give us what? A 14. So take note about that. So after you found the values, what you're supposed to do is to test these values that you have, all right? So in this case, we just have a single solution, but we are supposed to test this solution that we are given. Does it satisfy this equation that we are given? If our x is equivalent to what? To 14. If we substitute that 14 here, what are we going to have? This is going to be the square root of 14 plus 2 on your calculator. This is the square root of 16, which gives us a 4. So that means that truly our x is supposed to be what? To be 14. All right, so like I said, these are the stages that you're supposed to make to isolate whatever that you're given, which is the surd. Then after isolating that, you're supposed to solve. So you can properly see that on question number 3, where there's, on question number 2, I mean, where there's a need for us to isolate. We are given the square root of x minus 3 plus a 3 is equal to 0, like that. So if we check on the left-hand side, there is a term, there's a number that we are given, a positive 3, which is not part of this square root. It's not even part of the square root. So as we want to make the surd, the part that is under the square root, the subject, that is to isolate this. So what is affecting a plus 3? How do you remove this? You transpose this to the other side of the equation. It becomes what? A negative there. So it becomes the square root of x minus 3 is equal to a minus 3. It was a positive. The moment it crosses or jumps the equal sign, it changes its sign. Then we square both sides. So we're going to square this side, all right, to remove what? To remove the square root. So we are left with what? X minus 3. We have removed the square root. So this, to square both sides, is to remove the square root on the side. To remove the square root, all right, to remove the surd. Let us just say to remove what? The surd, the part that is under the square root. That is the purpose of squaring both sides. All right, so at this case, we can solve from here. We can solve, like I said, minus 3 squared, it's a positive 9. Then we can transpose a negative to this side, it becomes a positive 3. So x gives us a 12. If x is 12, does this satisfy this equation? Are we going to obtain a 0? If we substitute a 12 here, we're going to have the square root of 12 minus 3 like this. All right, whatever that we obtain, we add a 3. All right, are we going to obtain a 0 in that condition? All right, let us bring our calculator and see if this satisfies our equation. The square root of 12 minus 3. So this is 12 minus 3. Whatever that you have here, you add a 3. So this is going to give us a positive 6. All right, meaning to say our x in this case, the one that we are having here, is not giving us the exact solution. All right, because we are supposed to obtain this 0 here for x to be what? For x to be equivalent to 12. So meaning to say our x is not equivalent to 12. All right, take note here, everything is fine. You squared this, you took this to the other side. That is minus 3 squared like this. You are squaring everything. So it's negative 3, everything squared like this. Negative 3 squared, which gave us what? A 9. We transpose this negative 3 to the other side, which becomes a positive 3. We add, it gives us a 12. But at that condition, when we are to substitute it back now, when we are to take this solution back, we are seeing that we are not having that exact solution that we are supposed to obtain in that case. All right, so this is simply to say that the x that we are having there cannot be equivalent to what? Cannot be equivalent to 12. So it can be like that. It can be like that. So you are supposed to work with these questions that you are given each and understand how they are given. All right, how they are given, each and every part. All right, so you're going to check another part of our question. So in this case here, like I said, we can just say no solution. All right, let us check the other part of the question. You have to test these values. All right, always test your values. If you check on number 3, something that is just direct. We're not going to answer all these, just going to try 1 or 2, then you try them as an individual way. There's a challenge, we redo those questions together. All right, number 3 is a direct question again. 3 square root of x is equal to 2 the square root of 3. So what are we going to do in this case? Isolate, make the said the subject. So what is affecting the said? It is 3 that is multiplying. It's not adding, it's multiplying. So what do you do to remove this part that is multiplying? You divide. This time you do not add anything or subtract anything. You divide since you're multiplying. So we are left with the square root of x, which is equal to 2 square root of 3 over 3. How do we remove this square root? We square both sides to remove the square, to remove the said. We are going to square both sides. So x is going to give us what? Again, we can use our calculator on this part. All right, so let us just see what are we going to have at the end. There we can just use your calculator, guys. Open a bracket, a fraction, 2 square root of 3. This is 2 square root of 3, everything over 3. No one is going to know that you have used a calculator there. So you can just use a calculator. So x is going to give us what? 4 over 3. Then also, let us test our solution. If we substitute this, are we going to obtain 2 square root of 3? If our x is what? If our x is given as what? As 4 over 3. We had 3 square root of, it was 3, the square root of our x being what? 4 over at 3 like this. All right. So this gives us 2 square root of 3. So if we check on the other side, this is exactly what we were given, 2 square root of 3. So it means truly our x is what? Our x is 4 over 3. This is the exact solution. But if we check the previous one, when we substituted that value, it was not matching what we were supposed to have or what we were supposed to obtain. So that was not a solution. All right. Let us check another question. Again, these are the typical questions. You just have to follow these stages. Isolate or to make the subject, square both sides, solve for x, and then test your values. All right, so it's the same thing as what you see on number 4. I want you to try that. Make x the subject. All right, you square everything. All right, the same thing on number 5, but that type of an equation that you're going to get on number 5, it will be different from our normal equation. All right, let us just see. The square root of, so there we are given the square root of x squared plus a 7, then minus 4. All right, so there, this part is the only part under the square root. Minus 4 is not part of the square root. So there is a minus 4 there is equal to 0. So like I said, the first thing, isolate what? The square root. Make the square root the subject. How are we going to make the square root the subject? We have to square both sides. But before that, I mean, what are we going to do to isolate this? We're going to transpose this, all right? The minus 4 to the other side of the equation. It becomes what? A positive. We are subtracting. This is not a multiplication where you divide, all right? And also, if you check on number 4 here, it is a division. So you simply have to multiply by the square root of 2 here, the square root of 2 here. This cancels, you're left with the square root of x. So the square root of x is equal to 3 times the square root of 2 times the square root of 2. You just have to square both sides there, you solve. All right, but on this one, it's a subtraction. You have to transpose to the other side so that it becomes a positive. So we are left with the square root of x squared plus a 7, which will be equal to what? A positive 4. We have transposed this, it becomes a positive. Square both sides now. To remove the z, we are going to square here, we square here. So that is, we are left with x squared plus a 7, that is equal to 4 squared, which is 16. Like I said, the type of equation that we are obtaining is different from the one that we had before. Before we were obtaining linear equations, x minus 3 is equal to 7. You just have to transpose this, x is equal to 7 plus 3, which is x is equal to 10. It's a linear. This one is now a quadratic equation. A quadratic equation, meaning to say we are going to obtain two solutions there. Yes, we can transpose the 7 to the other hand of the equation. So that means x squared is going to give us what if we subtract 16 minus 7. All right, so let us just see what are we going to have in that case. 16 minus a 7 like this, that will be a 9. So you obtain a 9. To find x, it's x squared. How do you remove the square? You were introducing a square to remove the square root. Now you have a square. How do you remove it? You vice versa by the square root this time. So this time you introduce what? The square root. So that is the square root of 9. Remember, the square root of any number is what? Plus or minus. But we have to test now. Which of these solutions is true? Is it the x that is equal to 3, or is it the x that is equal to minus 3? Which one satisfies this equation that we are given? All right, so this was our equation, remember? So let us just substitute the first one, which is 3. That is the square root of 3 squared. So that is a 3 squared plus a 7 like this. Then you move on, you subtract a 4. So this must give us a 0. All right, so if you check, we are getting a 0 there. So that means it truly x is supposed to be equal to 3. All right, let us test this when x is what? Minus 3. So we just have to change here and see if we are going to get a 0. That is, in place of this, we're going to put a minus 3. So it's minus 3 squared like this. So this gives us a 0 also. So that means x also is supposed to be equal to 0. So therefore, these are our solutions. X is supposed to be equal to positive 3, or x is supposed to be equivalent to what? To a negative 3. That's the plus or minus is working. All right, so you have to test, because sometimes you will see that one of those solutions is the one that is working, another one is not working. And like I said, on solving of the equation, you have to check the type of equation that you are given. Here it's a quadratic equation, and it's different from a quadratic equation of this nature. X squared plus 2x is equal to 7. There you have to transpose this side. You use your quadratic formula or factorization method. Here there's no need for that. Yes, we can transpose this so that you can use the difference of 2 squares, but you can even use that way. All right, that was our question 5. So this is what you're going to do to all of these questions. You are going to apply the same calculations or the same way that I'm using here. Let us just check for a question that might be a little bit different. But all of these questions, as you can see, is the same approach. You just have to transpose. All right, sometimes you can even have an expression, like for an example, you transpose whatever that you have, you obtain a quadratic expression different from this one, like what is happening on number 7, on number 8, on number 9, on number 10, 12, and so on. So I'm just going to try 1 or 2 questions there. Let's try question 8, where we are given the square root, that is the square root of x plus 5. In this case, minus x is equal to 3. All right, so like I said, the first thing is to isolate the square root, the surd, to make the surd the subject. What is affecting the surd is the minus x. How are we going to affect this? Transpose it to the other side of the equation, it becomes a positive. That means we've got the square root of x plus 5, which is equal to x plus a 3. The moment we are having this, we square both sides so that we remove the square root. So that this here, the surd, is removed. So you're left with x plus 5 equal to, this side we have to square. But remember from our grade 10, how you expanded this, we have to expand x to the exponent of 10, x to the exponent of 2 here. So that's x to the exponent of 2 plus the first and last, you multiply them with these 2. So it's going to be 2 times the first times the last. So 2 times 3 times x is going to give us what? 6x. All right, plus the last squared. So we take the last term squared. 3 squared gives us what? 9. Or you just expand your brackets properly. 2 brackets, you expand them, you're going to get this. Or use the concept that we used previously from our grade 10 concept. All right, since this is a quadratic equation that we know, one of the side must be equal to 0 from the concept ax squared plus bx plus c is equal to 0. So you can transpose all these terms. So that's 0 is equal to x squared. Transpose x this side, it becomes a minus x. So 6x minus x, that is going to be a 5x. Transpose the 5 this side, it was a positive 5. This side, it becomes a negative 5. So 9 minus 5, it becomes a 4. So if a is equal to b, is the same as b is equal to a. So if 0 is equal to this, it simply means also this must be equal to 0. So you can even write it from that side. X squared plus 5x plus a 4 must be equal to 0, like that. So this is what we are going to have at the end. As we can see, we are left with a normal quadratic equation. The coefficient of x squared being 1. So we can apply our factorization concept, x and x here, to obtain x squared. How do you factorize? Considering the factors, the terms of 4 that you're going to add to give us a positive 5, that is 4 and a 1. If you multiply this, 4 times 1, that's a positive 4. If you add, you get a positive 5. All right? Negative 4 and negative 1 is not going to work, because if you add these, you get a negative 5. All right? Not a positive 5. But if you multiply, you get a positive 4, which is true. But we are not getting the positive 5. We need a positive 5, not negative. So the numbers are 4 and 1. So we're going to have here plus 4 plus a 1. One of these brackets must be equal to 0. So x is going to give us what? If one of these brackets is equal to 0, it means x is going to be a minus 4 transpose, or x is going to be what? A positive 1. This side, it becomes what? A negative 1. So these are the solutions. But what you're supposed to do is to test them as our final thing to test. Is it going to satisfy our equation that here, if we substitute our x that we are given on the left-hand side, we are going to obtain a 3. If our x is what? If our x is a negative 4. So take note, the first value of x here is a negative 4. So we are given a negative 4 on x. All right, let us just put a negative 4 here. All right, let us have our calculator here. All right, so that is the square root of a negative 4 plus 5, negative 4 plus a 5. All right, whatever that you have, x again, it's negative. So remember, there's a minus of the formula. The x that we are having, it's a minus on its own. So that's a minus 4 like this. Are we going to obtain a 3? That is the case. We are obtaining what? A 5, not a 3. So meaning to say this here is not our solution. All right, let's move on to -1. If our x is -1, meaning to say in place of x, we're going to put -1, in place of x, -1. So this is it here. In place of x, we're just going to put a -1. So this is a -1. In place of x here, we are going to have a -1. So this gives us a 3, which is the one that we are having here. So that means x in this case is supposed to be what? A -1. The one that satisfies the equation that is giving us what? A -3. So therefore, x is equal to -1, not this one. So here there is no solution on this one. No solution here, or not applicable. Okay, so that is how you're supposed to solve this equation. That is the same thing. Maybe you can just try number 12, but if you check, there's just one and the same thing. Let us just try number 12. But like I said, try as many questions, solve your equations. You're going to use the quadratic formula, the factorization method. It's up to you. But in most cases, just try to apply or use your factorization method. On question number 12, we are given x plus 2 square root of x minus 1, which is equal to 4. So I again isolate the root. All right, so you can remove the x there, transpose it to the other side. It becomes what? A negative there. That's 2. The square root of x minus 1 is going to be 4 minus x. All right. But before that, before you even isolate, because we want to square. But before that, there's a 2 that is still affecting here. So how do we remove this? We have to divide by these 2. Divide by these 2. That means we are left with the square root of x minus 1, which is equal to 4, minus x, everything over 2. Then that's where now we can square both sides to remove the z. So here we can just square both sides of our equation. All right, so this is our equation here, guys. Let us square both sides. So if we square here, if we square this side, and we also have to square. So this one, we're just going to square everything like this. So to square is to remove the square root. That means we are left with x minus 1 is equal to 4 minus x squared. So this is 4 minus x squared over 2 squared. Everything is affected by this square. All right, so like I said, if you're given to the exponent of 2 is going to be the first term squared. That is 4 squared is 16 minus 2 times the first term, which is 4 times the last, which is x. So if you multiply this is going to give us 8x plus the last term squared. The last term is x. So it's going to be x squared. Everything over 2 squared, which is a 4. All right. So not to affect this equation, just cross multiply. Just remove this 4 by cross multiplying. All right. Just multiply by 4 this side. So it's 4 times this x times this minus 1. All right. 4 times x. That is going to give us 4x. 4 times minus 1, which is going to be a minus 4, is equal to 1 times this. So we are going to remain with what we are having here, which is simply, we are going to remain with what we have. We're going to have x squared minus 8x plus a 16, which is the same way that it was written. Like I said, on this one, we have to make one of these sides to be equal to 0. So 0 is equal to x squared. Transpose 4x this side, it becomes a negative. So we've got a negative 4x there, which is negative 12x minus 8 minus 4. Transpose the negative 4 this side, it becomes a positive 4. So that means we've got a positive 20. So from this now we can solve our quadratic equation. Ow. All right, we can make this side to be equal to 0, just like what we're given. X squared minus 12x plus 20 must be equal to 0. So by factorization method, we've got an x here, we've got x here. What are the factors of 20? But these factors should give us what? A negative 12. So as you can see, there's a negative there. It means the numbers that we are talking about should carry negative so that it gives us a positive 20. Talk about 10 and a 2. We get a positive 20. If we add, we get a positive 12, not a negative 12. So what do we do so that it gives us a negative? We simply have to introduce a negative here, a negative here. If you multiply, it gives you a positive. If you add, it gives you a negative 12. So that's a negative 10 and a negative 2, which is equal to 0. One of these must be equal to 0. So x will be equal to what? A positive 10 if you transpose it to the other side, or x is going to be equivalent to a positive 2. All right, it was a negative 2. Transpose the other side, then we can test our solutions. Now, x being 10 or 2, does it satisfy our equation? If we substitute one of these solutions here, are we going to obtain a 4 on the right-hand side? All right, so the first solution that we had, it was a positive what? That was a positive 10. So you're going to try to substitute a positive 10 in place of x. You're going to put a 10, a 10, a 10 in place of x. So that part you can just even use it direct on your calculator. For the simplification purposes, you can just use your calculator there. That is x being 10. So 10 plus 2 the square root of x minus 1, which is 10 minus 1 under the square root like this. We are expecting what? To obtain a 4. This is what you're expecting to get. All right, let's simplify. This gives us a 16, not a 4, but a what? A 16. So meaning to say this is not a solution. We move on to our x when being what? When being a 2. Are we going to get a positive 4? All right, so let's substitute where there is x here. We substitute a 2. Where there is x here, we substitute a 2. So this is going to give us a positive 4, exactly a positive 4. That means this is our solution. X is equal to 2. Here we do not have a solution on this one. X cannot be equal to 10, as we saw from the proof that we had, that x cannot be equal to a positive 10, but x is going to be what? X is going to be equal to a positive 2. So therefore, our solution here is x is equal to a positive 2, not 10. All right, so this is how your questions are given as. You just have to play around with these typical questions. As you can see, there are so many questions to consider. You can work as much questions from there. If there is a challenge, let me know so that we can revise or redo those questions together to work on this exercise on the questions that are still having a challenge. But for now, that's how you are supposed to attempt these typical questions.